Welcome. Sorry for the late start. This talk so far, I'll just preface this. It's been riddled with technical issues. I know in the description it said we'll be doing a demo. Unfortunately, we had some hardware issues, and that makes that kind of impossible this morning. I wasn't able to locate another desktop power supply to power our equipment, but we're gonna make the best, and I hope y'all enjoy it. So get started. The name of the talk is DMA Tax for Fun and Profit. I'm Daniel. This is Zaylen, and we really wanted to do a talk and research the current state of DMA attacks. And over the years, there have been several protections built out, not only by IBM and Intel, but also Microsoft updating some, like with Windows 11, forcing memory integrity options and things of that nature. So we wanted to kind of do a talk and go over the current state of it. So a little bit about us. So like I said, my name is Daniel Hampton. I'm a red team security engineer. I've been a red teamer 15 years now. It seems a lifetime, really. I've always been passionate about security and hacking in general. Um, some of the things outside of hacking, would like to go hiking and traveling and stuff with friends, spending time with this guy and his brother. Um, and you want to introduce yourself?
Yes. So I'm Zaylen Hampton. I I'm all new to this stuff. I put together the slides around like 3 days or so. Everything new to me, but I what I like to do, I I like to make video games for myself. I would like to become a game developer at some point in my life. I'm currently making games as an indie game developer. I do it solo by myself, just as a hobby. And I mod other games and stuff. But what I want to talk about is DMA attacks today and other ways to get past like pins and stuff.
Sounds good. So always got to start with a nice quote, right? So here we have a quote from Jim Lagnevin. Um, Effective cybersecurity is not a product, but a process. And this to me kind of it's more of a constant learning process, and not necessarily just a one size fits all product that we sell to customers that fixes it and makes everything secure. Um, so what will we go over today? First, we'll go over what is DMA. Um, what are some of the vulnerabilities with DMA? What hardware and software are used to exploit those vulnerabilities traditionally, and how that's kind of changed over time. The current state of DMA attacks and the mitigation efforts that have been worked in, and um, other uses for DMA attacks. As you'll learn, although security around like from a corporate standpoint may have improved, there are other um, attacks or other use cases for DMA attacks that have actually become much more popular than I think the original use case that was put forth. But we'll look at the mitigation techniques for those type of attacks, and then also, so as a side note, when we started this talk, one of the goals that I wanted to achieve with this was bypassing BitLocker encryption. So traditionally, DMA attacks have been leveraged for that type of thing, to get a system shell on a machine that's already booted up, and thus, BitLocker's already decrypted the drive, and then mounting that drive and viewing the contents. As you'll see later in the talk, Microsoft and Intel and IBM have done a lot of great work to mitigate these type of attacks nowadays. Um, and in order to disable those mitigations, you need access to the Windows host foremost, so it blocks a lot of those. However, there are other methods, and the method that I used was a cold boot attack to actually gain those BitLocker encryption keys eventually. Um, so let's start at the beginning. So what are DMA attacks? So DMA is just direct memory access. So a long time ago, I won't go into extreme technical details, but essentially, the way that the system buses work in computers, you had the data bus, and anytime a piece of hardware like a audio card or a graphics card needed to read from the RAM or interact with the RAM, there was no direct memory, there was no direct access to that. So the CPU would have to handle that load, right? DMA was a technology that IBM and Intel created, um, and it allows for hardware components to directly have direct access to memory channels, right? So without the OS or the CPU having any involvement in that, and it's a great thing. It speeds up like modern graphics cards and a lot of modern hardware wouldn't be nearly as fast as they are as far as their bandwidth and communication speeds without DMA. So it's definitely something that is useful. However, as we'll see, originally there were some pretty glaring, I wouldn't say glaring, but there were some vulnerabilities. As we see with a lot of technologies and standards, they're great and they change over time because vulnerabilities are discovered because we're all doing our jobs. So um, that's kind of the overview of DMA. So a DMA attack, as you can imagine, is using there are several methods to achieve this. The method that we're going to talk about today is using a hardware card. Um, this is just a PCI Express. My mind, I'm so sorry. I have another slide that'll go into more detail on that. But it's a PCI Express card. That's called a PCI Screamer Squirrel. And it allows you to connect to the um, the M2 or oh my goodness, my mind is going blank. I apologize, y'all. It allows you direct access to the bus. And in this laptop, that was achieved through the M.2. There's a B key that's typically used for Wi-Fi. Um, so the thing with DMA is it allows, like I said, it allows hardware devices for direct memory access. So PCI Express, Thunderbolt, things of that nature have that, those are allowed that direct memory access. That's where the exploitation and the vulnerabilities come in because, we're able to design our own cards and have them achieve things that weren't originally thought of. So um, like I said, this red card here is a PCI Screamer Squirrel. It's made by Lambda Concepts, and in combination, there's a gentleman named Ulf Frisk who did a lot of research on this, and he's given several talks at DEF CON, CCC, and a lot of other conferences. Um, and really, all the credit goes to him for the library that allows the communication between this and the victim machine and the attacker machine. It's a library called PCI Leech. Um, a lot of great work that's gone into that, and it's it's just a great tool that allows a lot of this, to be possible. There's other exploits and tools that have come along. Just PCI Leech has a wide range of compatibility, and it's very well maintained, very well documented. Um, and it allows you. So the way that this works is um, it essentially uses kernel implants to exploit the Windows OS and do things like mount the encrypted file system, or we all remember the sticky keys hack back in the day, right? It can auto patch Windows so that when you do the sticky keys, you don't have to um, pre-copy over any exes. It's already patched and it'll just load you a system shell, right? Um, So just to go into a bit more detail, so DMA attack is just a type of side channel attack. Um, and there are two different types. So if you're using Thunderbolt or PCMCIA, I know that's an older, technology, but those we would you don't have to remove the case, like they're much less invasive. With this, obviously you had to remove the case, get access to the M2 slot, all that type of stuff. There are different methods to do this, and like I said, it allows you to really do things like bypass the login screen. Um, there's various kernel implants that are built into PCI leach, so you have a lot of options when it comes to that. And there's also a GUI that's been built around PCI leach called um, Pushpin, which allows you to like execute a lot of those things using pretty GUI and not have to memorize or script out the commands as well. Um, so I, I actually spoke. I apologize. These slides, like I said, were constructed really quickly. So um, I went through them a few times this morning. But so as I had mentioned before, there's various ways to access that. So there's the closed chassis attacks and an open chassis attack. Obviously, like you take the case off, it's an open chassis attack, and then the if you're using Thunderbolt or any of those other methods, closed chassis attack. Um, and like it mentioned, although there are other methods, the machine that we were doing the testing against, it didn't have Thunderbolt or any of the other methods. So that resulted in finding an M2 slot that was open, not being used by a drive already, and then finding various adapters to adapt it to PCI Express 1X so that we could attach the card. So a little bit more about the device. So the Screamer Squirrel is just a FPGA, a field programmable gate array, which just it's a system on a chip that allows you to flash firmware and use in a development, environment, uh, used mainly to design and develop or debug, troubleshoot equipment. Um, it connects to a PCI Express 1X port, and then it has two USB-C ports on the front of it. One of those ports is used to flash firmware to the device. The other port is used to connect to the attacker machine. If you see in the picture here, um, you can see the M.2 card is attached to the motherboard here. Got this ribbon going across to the riser here, the PCI Express riser, and then just USB running to this laptop, which you can't see in the picture, but it's there, I promise. So, so as we mentioned earlier, there are various other uses, and a lot of the research, like watched Ulfris talk several times, and he mentions this in his talk as kind of an unintended consequence of when he designed PCI Leach. And one of the biggest use cases that's kind of morphed in recent years is online game cheating. So the way that this works is you literally use this same setup, and on this on your victim machine, you would be running your memory analysis, your hacks. So what these cheaters will do is they'll buy custom firmware that they load onto their FPGA device. And some of these firmwares, like we're doing research for this talk, I was honestly shocked at some of the prices that people are paying for cheating firmware for games like Counter-Strike and Call of Duty, Valorant. Like I'm talking thousands of dollars, like five to $10,000 for what a developer claims is, they call it a one-to-one firmware. So it's essentially a custom firmware, quote unquote, that only you have that custom firmware. So it decreases your chances of being detected and banned for cheating, right? Um, so who's to say if this firmware is actually one to one? These people are paying money, all this money for it, but people are buying it. This is people are doing this. And the way that it's undetectable is the card is doing all the memory analysis. And on the machine that's running the actual game, the Counter-Strike, Call of Duty, whatever the game may be, no memory is being written to. It's only reading the memory, right? So it's using this card to read that memory. On the other machine, they're running the actual exploit, which is creating like an overlay on the screen. Say in Counter-Strike, they want to see through walls, right? And I don't know how many of y'all have seen videos online. You can go on YouTube and see it, TikTok, whatever. And there's like videos of people with, walls, and you got boxes around all the characters all over the map. A lot of times they'll have lines drawn to them and all this stuff. They get pretty fancy, they do. Um, the issue is, right, so the hacks are being displayed on one machine, the game is being displayed on the other machine. So what they've done is they use a fuser to fuse those two HDMI connections so that on a single monitor, you're getting the overlay plus the game. So when the anti-cheat software is running on the game, whatever anti-cheat may be used, it doesn't see that overlay if it's taking screenshots. It doesn't see memory being written to. A lot of times, so with these custom firmwares, what they'll do is, change device IDs, things like that. It's become a cat and mouse game in the video game world with cheating, and there's apparently a lot of money in this. And it's become a big problem. There's a lot of money that's being spent on anti-cheat software, as well as, money that's being spent creating these cheats and circumventing them. So with all of this said, um, what is the current state of DMA? So as I spoke about earlier, there and just a note, before we got to this slide, we were going to do a demo. This is where we were going to actually show you the PCI leech in in um, in person. I'm sorry, we'll have to do a show and tell instead, but hopefully nobody throws tomatoes at us. But but so the current state of DMA is, as of Windows 11, I cannot remember the exact build or version number. I know Microsoft's changed that in recent years. I think it was 22H2. Uh, as of that version, Microsoft enables memory integrity and Windows kernel DMA protection by default now. So what that means is, if your enterprise is using, a gold image that is based off of that version of Windows 11 or higher, you're most likely have that enabled by default. So say an attacker were to get, a corporate device from a coffee shop and steal that device. So they have the device in their possession, so they can take the back off. Say there's no BIOS password set, so they're able to go into BIOS and disable Intel VTD and IOMMU, which are the memory protection. Um, Windows still has that kernel DMA protection and memory integrity protection inside of the OS now. So it will immediately, once those are disabled, it'll start throwing, as when you go to boot up Windows, it'll just throw a BitLocker recovery error, right? And it'll detect that there's an issue with the integrity, and it'll stop the boot. The only way around that is to, which would, if the attacker were trying to bypass a Windows password, obviously they wouldn't have the administrative password, to get in and disable those Windows features. But in order for DMA to work, like for the cheaters, the game cheaters, for example, like they have to go in and disable those security features or use Windows 10 or something like that, right? Um, Now, Windows 10 does not enable that by default. Um, so as far as I know, like unless maybe in a which I think now Windows 10 is going into life, so I doubt they'll be releasing a new release with that enabled by default. Um, but yeah, essentially that kind of blocks this from being used. One additional thing though that I would recommend to corporations is I know this is something that the industry and corporations have gone back and forth on over the years with BIOS passwords, because there's an argument that you know just setting a simple password is useless because somebody could guess it, and it would be shared across an enterprise of, say, you had 10,000 users. However, an attacker that stole that laptop, even if the password was, your company name and a random 4-character string, like they may not, you don't know their skill level. Like maybe they they would never guess that, or it would at least deter them, right? I think a BIOS password in a lot of cases, even if it's a simple one, can be um, a good addition to security, and it's a pretty simple thing to institute. Um, So this slide, it really is just kind of reiterating that. So on modern versions of Windows, DMA protection, and uh, and the way that DMA protection works is it works with that input output memory management unit, the IOMMU that is in BIOS. And that's how BitLocker detects any changes, and it trips the BitLocker recovery. Um, so outside of that, though, like I said, when we first started this talk, I really wanted to find a current method that can be used to bypass BitLocker encryption, because at the end of the day, we want to deliver something of value, something you can take back and to your organizations, and that would be useful, right? Um, so that's where this comes in. So cold boot attacks, they are an attack that have been in, I mean, they've been in existence for decades now, but they're not, if you go on YouTube, you go online, you try to research these type of attacks, there's more information that's starting to come out nowadays. However, there's not a lot of research and like demonstrations of this type of an attack. Um, so this one was really interesting to me because I saw recently, it was back in February, I believe, there was a new UEFI memory dumper tool that was released. Um, and my thought was, I wonder if this is still possible. I mean, you boot off UEFI. Um, the way, so the let me just I guess let me take it. I'm making a lot of assumptions here. So the reason we call this a cold boot attack is, for one, um you're rebooting the machine to do it. But I like, the word cold is especially important because RAM, a lot of people have the belief that once a computer is turned off, that RAM just erases. But it doesn't. Like once RAM loses its power, it slowly degrades. And there's ways to stop that degradation. And one of the best ways to stop it is to keep it cold. Um, so I know the name cold boot is referring to a cold boot of a machine, but cold really comes in handy for this. So that's where this can of air comes in. I'll talk about that in just a second. But one of the best ways to increase your success rate in dumping the memory without corruption and getting a good memory dump is by keeping the RAM as cold as possible. So how do they work? So the first step is you create a bootable UEFI image. One thing that I found in this research is typical USB 3, say, like for example, this laptop has 16 gigabytes of RAM. You're trying to dump this as quickly as possible before the RAM degrades. It's a battle, right? So one thing that I found on Amazon, I actually picked up an M.2 adapter. So I was able to use an M.2 SSD instead of just a standard flash drive, and that sped up the copy a lot. Um, so combining that with like a constant freezing of the memory, I'll show you a picture of that here in a second. I was able to get enough of the memory anyway to extract the BitLocker encryption keys, um, and from there decrypt the hard drive. So the way another thing I should mention. So once you dump the memory, I mean you're looking through a memory dump. It's never like a straightforward process. Um, But there are so Windows uses things called pull tags that are various system calls that are being made. And for example, there will be like a pull tag that may be related to BitLocker, um, the BitLocker subsystem. There may be another one related to audio. There may be another related like everything in Windows has a pull tag, and it's like their address or not their exact address, but a reference to them in memory. Um, so fortunately, there is a complete list of these pull tags, what they mean. So using that, we were able to search through the memory dump, and we came up with about 26 different instances where one of the BitLocker pull tags was being referenced, and like literally going through all of those and looking for um, uh, so the BitLocker encryption on this machine was using AES 128, I believe, and the identifier for that was 0440. So using that and a bunch of searches, eventually we're able to get the actual key, confirm it was a key, and decrypt the drive. Um, this kind of just talks a little bit more about things that can go wrong when you're doing this. So of course, like I said, RAM degrades, secure boot can prevent things from running at boot. And this goes back to the BIOS password thing. So with the cold boot attacks, you do need to disable secure boot in order to boot from that UEFI disk. So if you have a simple BIOS password, this could possibly or, prevent or deter at least a cold boot attack. And also, finding the full volume encryption keys, it was a pretty difficult process. That took the most time in this, just going through the memory. I don't do that every day, so someone who does would probably be able to go through that process a lot faster and without as many struggles as I did. But it was a fun learning experience nonetheless. So yeah. I really so we had so many cool demos planned for you all. I really wish that we could go into those, but there was another demo plan of a cold boot attack before this. But we'll kind of just recap. So as we were covering with the DMA attacks, there's just a side channel attack that people use to gain access to the computer by exploiting the presence of high-speed expansion ports. Um, so PCI Leech is, like I said, is the library that we used to conduct our testing. Um, Credit to Ulf Frisk really great work there. But it essentially is a tool set that allows an easy communication method. Although, the card has the capability, it would be, you'd have to write your own firmware, you'd have to write your own libraries essentially to complete that. Um, so the ways to prevent it, like I mentioned, um, Windows 11 does block this by default now, using IOMMU and VTD and enforcing kernel DMA protection and memory integrity. Um, Another thing, of course, the BIOS password is a great thing, in my opinion, to do. So here we have a picture of the memory finally. So there's our frozen memory, and it's already starting to thaw there, as you can see. And we use that image as an example because this picture, so this was about 30 seconds in, like that RAM heats up extremely fast when you turn the machine back on. You can freeze it all the way, think you have it good to go. And then as soon as you power the machine on, it starts defrosting. So it's like a, a dance to try to keep the memory frozen while you're, typing commands and doing your dump. So fortunately, the commands are pretty short, so that kind of helps. But yeah, so our talk, y'all, did not go as long as we wanted because, like I said, we had to cut the demos. However, Um, because of that, I know this is a talk and y'all are watching us, but if y'all want to check out any of this hardware, if y'all want to ask us any questions about it, um, or anything like that, definitely love to hear. Or if any of y'all have, done any research in this area and you want to share, what you found or anything like that, definitely open to it. We appreciate y'all's time.